Final effluent quality monitoring instrumentation. Instrumentation has recently been installed on the final effluent sampling points on many of your wastewater treatment works. The parameters being measured are ammonia, phosphate and turbidity. Some sites have all three, others have one or two of these parameters. The instruments are installed either in kiosks, purpose-built frames and cabinets, or in some cases just as a single instrument mounted on the handrail. All aspects of the maintenance of the ammonia and phosphate monitors is looked after by Servitech International. We attend each site with these instruments on either a fortnightly or monthly basis, and also provide a call-out service in the event of any problems between these visits. That number's manned 24 hours a day, 7 days a week, and we aim to attend site within 24 hours of the receipt of a call-out when site need us to do so. The routine cleaning of the turbidity instruments is not performed by our engineers. The information on the video clip covers the cleaning tasks that you need to perform yourselves. To familiarise you with the equipment and to aid diagnosis of any faults on the instruments, we have performed training sessions throughout Severn Trent. We have now also compiled the following short videos to provide you with basic information on how the instruments work and to show you what information is useful to us and how to get that information in the event of you needing to call us out to site. There is a booklet which contains all the details covered by these videos and the training sessions, and that's available either as hard copy or electronic format if preferred, and further training sessions can be performed if required. ProAM Ammonia Monitor. You currently measure your ammonia levels by performing spot checks using a portable colorimeter such as a Palin test. That works by mixing your sample with a reagent and a colour is developed. The more intense the colour, the higher the level of ammonia in your effluent. The ProAM performs this analysis for you, but utilises a slightly different technique called ion selective electrode. In order for the ion selective electrode to work, the sample's pH needs to be elevated to around 11.5 pH. To achieve this, a buffer solution needs to be added to the sample and mixed by bubbling air through the sample chamber. The buffer solution, sample, standards and wash solution are all drawn into the sample chamber by a peristaltic pump. This is a fixed speed pump with two different sized tubes, the smaller of which draws in the buffer solution. The fixed speed and fixed tube diameters give a known dosing rate to ensure the correct pH is achieved. The pump draws the samples through an array of pinch valves. The operation of these is initiated by the controller, which opens and closes them to allow the required liquid to be drawn into the sample chamber, i.e. sample, standards or wash solution. All of these solutions pass through a proximity switch. This will generate an alarm if the relevant liquid is not present in the tube, which will give an error message on the controller. The controller is a basic two-line LCD display with the top line showing the current ammonia value and the bottom line displaying any active error codes in the form of a letter and an asterisk either side. The error codes you may see are P, instrument has failed calibration. S, instrument has no sample flow. R, instrument has no reagent. L or H, instrument has no high or low calibration standard. And W, the instrument has no wash solution. If P is on the display, the instrument has failed its calibration and may require attention. The information that helps us in this instance is the OP span. To access this information, follow the button presses shown. enter, then X. Then the down arrow to data, then enter, then the down arrow to OP span, then enter again and record the number shown. The target number here is 60 millivolts. To exit that menu, press X twice. If S is on the display, the instrument has suffered a sample flow failure at some point. Check that the sample chamber is at least 2/3 full. If it is, then press the down and enter arrows simultaneously to clear the alarm. If the sample chamber is less than half full, then check that sample is flowing through the sample pot. This pot is a reservoir from which the ProAM draws its sample. The pot may have a stainless steel filter insert which can be removed for inspection and cleaning. If sample is reaching this pot but not entering the ProAM, we know that the problem lies within the ProAM, possibly a blockage or split pipe. To check the flow, either isolate the sample inlet with the hand valve, unscrew the lock nut, remove the collar, and then open the sample inlet again to see if sample flows into the pot, or more easily, simply pull the pot drain pipe slightly out of the tun dish to see if there is a flow. If sample is not entering the pot, we know the problem lies between the main sample pump and that pot, i.e. the sample pump located within the final effluent chamber, or the sample bypass loop. This loop delivers most of the pumped flow back to the final effluent chamber. The isolation valve is throttled back to force sample through the bleed line to the instruments. When flow isn't entering the sample pot, throttle the valve back further to see if this removes any blockage and improves the flow to the pot. If this is successful, open the valve slightly again and advise Servitech as further work may be required. If it is not successful, advise Servitech as the main sample pump needs attention. If R, L, H or W are on the display, this indicates that one of the solutions has run out. Visually check that the bottles beneath the unit contain liquid and contact Servitech. To check when we were last at site, check the engineer record sheet. This will be in a clear wallet on the front of or near to the instrument and will show the date of the last visit. This concludes the training on the ProAM ammonia monitor.